We're gonna do a left Riemann sum from a table with these numbers. And I'm gonna show you how. So you wanna start off by determining the number of subintervals. So to do that, you're gonna wanna look at the table, okay? You see how the table has like 5 different columns and we're doing a left Riemann sum. So like this is gonna be like one theoretical box of the sum, 2, 3, 4. So you're gonna have 4 subintervals. This could have also been achieved by just subtracting the number of columns by 1. But I'm not here to tell you how to live your life. So we're just gonna write this information down so we don't forget. So now we can get to the fun part, which is actually doing the Riemann sum. So the way you find the area for the Riemann sum is by multiplying and basically just doing, not even algebra, this is like grade school math, so you can totally succeed at this as long as you know the way to do it. So, apologize for the camera work. F of 0, because we're starting from the left. And then we're gonna look at the width between these two things. So 0 to 1, that's just 1. So f of 0 times just 1 plus f of 1, because we're going to the left, times how much is between 1 and 6? Just 5. Plus f of 6 times 1 plus f of 7 times 3. We just made it. So that's 9 times 1 plus 7 times 5 plus 9 times 1 plus 7 times 3. So that's 9 plus 35 plus 9 plus 21, which is equal to 74. What's poppin'? It's your boy John Cena. Just joking, it's still me. We're still learning about Riemann sums, but this time we're gonna do it from the right. I apologize for any background noise. Just the kids at this school be loud when I'm trying to do my work, but that's besides the point. So this is similar to doing a left Riemann sum, but you just start from the right. So you're gonna be going this way. So let's start. How many subintervals are there? So there are 1, 2, 3, 4, 5 columns. So they're gonna be 4 subintervals. Okay, so now why don't you tell me what the first step is? Good job. So I already know you said we're gonna take f of 0 and multiply it by 1 because, oh, actually if you said that you would have been wrong, so I take everything I said back. What you should have said was we're gonna take f of 9 because we're starting from the right. So you're gonna take f of 9 and multiply it by 1 because there's one space between 9 and 8. So f of 9 times 1 plus f of 8 times, I'll let you tell me, how much space is between 8 and 4? If you said 4, you were correct. So, you know, get that 5 on the AP exam. How much space? Oh wait, the next one is f of 4. How much space is between 4 and 1? Just 3. And then f of 1, how much space is between 1 and 0, which is just 1. So we have the whole equation written out. And now the rest is just like algebra, not even, it's just grade school math. F of 9 is 9 times 1 plus 7 times 4 plus 9 times 3 plus 7 times 1. And so, just in case you didn't catch what I did here, F of 8 just means what is f of x when x is 8? And in this case, it was 7. So that's how you do it for each one. So now we have 9 plus 28 plus 27 plus 7. I tried to write them kind of fancy. Kind of regret it. And the answer is going to be 71 because the queen of mental math strikes again. Thank you for watching. I hope you learned something. Go get that 5, kiddos.
Okay, so I'm doing the trapezoidal sum, trapezoidal Riemann sum, and so we're gonna start. The question tells us that we have to have 4 trapezoids to tell us the area under this function. And so first we're gonna look at the interval, and there's the difference between them is 2, because it's -4, it's a -2. And if we want 4 sub-intervals, we're going to divide that number by 4. So that means that the width of our trapezoid will be 0.5 or 1/2. And then to find the 2 points, we know that the first point is -4. So we will just plug it into a trapezoidal formula, the area for a trapezoid. So -4, f of -4, plus f of -3.5, because if the difference of the trapezoid is 0.5, so this trapezoid is 0.5, and then, or 0, and then you take away 0.5, it's -3.5. And then you're going to multiply that by 0.5, which is the width of the trapezoid, and then divide that by 2, or we can just divide the whole thing by 4, because we're going to be multiplying by 0.5 again, so it's easier to just think about it that way. So that's one of them, plus f of -3.5. Okay, f of -3.5 plus minus another half, so that's, or not half, but 0.5, so that's -3, and then divide that by 4. And then we're gonna keep doing it, so -3, and then add that with f of -2.5, and then divide by 4. And then so that's 3 trapezoids. These are the area of 3 trapezoids, so just 1, and we're adding these areas together. F of -2.5 plus the area, or not the area, but okay, 2, -2, and divide that by 4. So these are, when we calculate it, we will calculate it in numbers. Okay, so we're gonna plug in the value of -4 and try to find f of -4, so we can plug it into the original equation of a trapezoid, the area of a trapezoid. So we will just plug in -4 as x, so the -4 squared over, oh, this is supposed to be 2. 1 second. So it's negative 4 squared over 2 minus negative 4, so that's plus 4 plus 1. So negative 4 squared is 16 over 2 plus 5. This is 8 plus 5, which is 13. So f of 4 is 13. Okay, so once you find the f of x's and find the area of the trapezoids and add them together, you should get this number.